So I've just published this week's section, which is here. Now I've hidden, obviously there's a lab this week, but I've hidden it for the moment. I just need to make one change to it and I'll reveal it later on today. Essentially, it's a continuation of the Movies fan app. So there's two main topics this week. I want to look at navigation, adding navigation or routing to our React app, and also I look at an area called design patterns. But before I talk about either of those, I want to go back to JavaScript and mention one or two syntaxes that we haven't looked at all so far, and that was intentional, really. And we'll come back to JavaScript maybe on another occasion as well, when there are other parts of the language that we may need to know about, because I use them in the code that I give you in the labs. So there's only 2 or 3 slides in this behind this card here. So let's start there. And there's code accompanying this short set of slides. And as usual, you'll find the code in the archive linked with this section. Essentially, there's 2 parts of JavaScript that I wanted to look at, and these 2 parts were introduced in ES6. One is called destructuring, and the other is called the spread operator. I'm mentioning default arguments as well in this slide, but I'm not really too concerned about that part of the language. I'll just briefly explain the syntax behind it, okay? But I don't think I use it at all in any of my code, but I certainly use the first 2 features there. So destructuring first. The idea of destructuring is if you've got an object or an array and you want to assign individual elements within either of those structures to separate variables. So if you've got an array of 3 elements and you want to assign those elements just to separate variables. Now, there's 2 ways you can do it. This is the old-fashioned way, I guess we could say. So I have got my array here with 3 entries in it. And I'm just making standard assignment statements, declaring 3 new variables, v1, v2, v3, for whatever reason. We don't need to go into the why. So, however, it's kind of long-winded. What destructuring allows us to do is essentially to do condense these 3 lines into one statement, and that's what you've got here. So we would now say this is an example of destructuring of an array. The net effect is the exact same as what I'm doing up here. So the effect of what's happening here now is we're declaring 3 new variables, v1, v2, v3. And because of their positioning here on the left, v1 is going to be assigned to the first element in this array, v2 to the second one, and v3 to the third one. And it's as simple as that, really. It's what we say is that this is a more declarative way of expressing what I want to do up here. But the net effect is still the exact same in both cases. So you're using, and because I'm using the angle brackets here, that is telling me that the thing on the right is an array. In fact, it has to be an array. It won't work otherwise. We can do a similar kind of destructuring of objects. So if we take this example here, without destructuring, so I've got 2 key value pairs in this object. Without destructuring, this is what I'd have to do. I'm declaring a variable called alpha and assigning it to that property value, similarly here. However, with destructuring, I can express it like this. Note I'm using the curly braces here. So the curly braces tells me that the thing on the right is an object as opposed to an array. And also what's happening here now is the runtime goes looking for a key in this object called alpha. And assuming it finds it, it takes the value associated with that key and it declares a new variable called alpha and assigns it that value. Similarly with beta. So alpha and beta do have to match the keys in the object. Although we will see in a second that you can actually overcome that kind of restriction. So we're trying to look at this sample script. And so as I said, to get the code, just grab the archive on the right there, download it and unzip it. And when you do so, you will see something like the following. Okay, we look at these two folders later on. This is the folder we're interested in now. And so here's 01 destructuring. And to run it, we're just going to use ordinary node command line. So it's going to be node 01. And it outputs some stuff onto the screen. And so let's step to the code very quickly. Again, this is really what I had on the slide. So this is what you'd have to do without destructuring. This is what you can do with destructuring. So we've kind of seen that already. So the console.log here is generating this down here, and it looks like it's working. It's declaring v1, v2, v3 correctly for me. So that console.log is producing what you see at the bottom of the screen there. By the way, if you're wondering why am I wrapping this bit of code in parentheses, and I'm wrapping the above bit of code in parentheses as well, that's just so that I can reuse the kind of variable names v1, v2. Like I'm declaring a variable here called v1. Now the net effect of this statement here is to also declare a variable called v1. And ordinarily, the runtime would complain about that because it says you already have a variable called v1, you can't declare a second one. But because I've wrapped the code in curly braces, which is a block in JavaScript terms, it means any variable that's declared within this block is only visible within the block. Okay, that's the only reason I've done that. Let's look at another example. So it turns out the destructuring is a bit more flexible than you think. So if we look at what's going on here, it looks like, okay, I've got my array here, but I'm only interested in picking out the second entry, and the fifth entry in the array. I'm not interested in the other ones for whatever reason. So the commas there are kind of significant. The kind of comma says, skip the first entry, now declare a variable called v2 and assign it to the second entry in my array, which is subscript 1, as you know. Then skip the third and fourth, and then declare a variable called v5 and assign it to the fifth entry in the array. And so that's why I'm getting down here, I'm getting these two values from the console.log, from this console.log. The fact that you can see here that there are six entries in my array, the fact that there are other entries in the array after the fifth one, it doesn't matter. Okay, you don't have to, for example, put another comma there because there is another entry after it. It'll just ignore the rest of them. Similar kind of illustration going on here. Okay, and that's it for arrays, really. That's destructuring of arrays. So it's just a shorthand, really. That's what destructuring is. For objects, well, this is what I want to achieve without destructuring. This is what I want to achieve with destructuring. But equally, there's a little bit more flexibility available to us. So here, if we look at this example here, okay, I've got alpha and beta as my keys again. Now, what I'm doing here is I want to declare two variables, but I don't want to call them alpha and beta. I want to call them num and word. So the way you kind of interpret this here is you're asking the runtime to go find the key inside an object called alpha and take the value associated with that key and assign it to a new variable called num. Similarly here, you're saying, go and find the key called beta inside in this object, take the value associated with that and declare a new variable called word and assign it that value. And so when I console log num and word here, I'm getting this line here. That's a way of kind of, you're not restricted to declaring your new variables that have the same name as the keys in your object. That's essentially what this is allowing me to do. Up here, the impression might be that you can only declare variables that are matching the keys in the object, and that restriction does not apply. What's going on here? So sometimes you're not interested in all of the properties in the object. So this object here has three properties, alpha and beta again, but it also has a property called foo with a value associated with it. And so it looks like I'm only interested in foo and alpha. I'm not interested in beta. So, a bit like the array, there can be other entries in the object, but you're just ignoring them. So, and again, if I wanted to rename them, then I could, I can still go foo, rename it to something else. That's all still going to work fine for me. So it's destructuring when you're only interested in a subset of the properties. That's what you see more often than not. And that's what you'll see me using in the, React code. Dare I ask, are there any questions? There never are, but it doesn't matter. Okay, that's destructuring. As I say, you'll see it a lot and you'll be using it a lot. I don't want to save anything there really. I'm just going to undo. Can I undo? Oh, I don't. Okay. Talking to myself. That's destructuring. Next is the spread operator. The spread operator is these three dots that you will see me using in the code. And to explain it, so JavaScript as a language has two types of iterables, that being arrays and objects. An iterable is a structure that you can iterate over, as in maybe in a for loop. So where the spread operator comes in is here. If you prefix the iterable structure with these three dots, then as the name kind of suggests, it essentially spreads out the elements of that iterable into individual parts. And you would use the spread operator anywhere you would ordinarily expect to have 0 or more kind of arguments in an expression. And there are a couple of places where that arises. So again, this is how we use it, right? We stick the three dots in front of our iterable structure, and it essentially spreads out the individual elements of that array within whatever expression this is being used. So examples always hopefully make things a little bit clearer. So let's look at the second script. And there are a couple of use cases for this spread operator. So here's number one, and I'm saying the use case is when we want to embed the individual elements, we want to embed the individual elements in an array into another array. So here's my small array, let's say, and I want to embed the mid array inside in this array. Now, if I do it like I'm doing it here, then all that is doing is it's adding a new entry to this array where the new entry is an array itself. So that would mean the first entry is an integer, the second entry is an integer, the third entry is actually an array, the fourth entry is an integer, fifth entry is an integer. Now, if that's what you want, that's fine. But if what you really want is to take the individual elements in the mid array and actually include them or embed them in this outer array, then what you do is stick the spread operator in front of the inner array. And now what that is going to do is what I've just said. It's going to actually take this array's elements and spread them out inside in this containing array. So if we contrast these two console.logs here, if I run it, so the first console.log did this. And if you can see, all it's done is it's just included the array itself as an entry, as an element in the containing array. Whereas the second console.log does this, it actually takes the 3 and the 4, and it just includes them as ordinary integer elements in the containing array. That's one illustration here. What we can use the spread operator is to make a copy of an array. So here's an array with 3 entries in it. If I simply make an assignment statement like that, clearly that's not making a copy of the array. It's only assigning a new variable to the same array. So if I do a push onto array 2 and I push this character, the character D, onto array 2, when I do the console.log of array 1, as I'm doing here, it's going to have that new character in the array. So that's kind of proving to me that really that statement there, as you probably know anyway, that statement is not making a copy of the array. However, this statement here is making a copy of the new array. This is effectively, this statement that I've highlighted is creating a new array. It's taking the elements in R1 and it's spreading them out inside in this new array that I've created. So now if I do a push onto array 2, when I console.log array 1, it won't have the new entry that I've pushed onto array 2. So that would prove to me anyway, that this statement here is kind of quick-handed way. Sorry, this statement here is a nice shorthand way of creating a copy of an array. Yet another use case, well, okay, if you've got a string and you want to create an array consisting of the individual characters in the string, then that's what that statement does. Probably less usage, less need for that in our code, but there you go anyway. Now, in relation to objects, you can use the spread operator. So here's an object that contains some details about me, I suppose. And this is an array that, or sorry, an object that I would like to contain all of the details about me. So what I want to do effectively is I want to include the part of me object. I want to include it in the all me object. Now, one way of doing it is by just sticking the smaller object inside in the larger object, just like that. But that's really going to be the same as our kind of first illustration in the array case. All this is going to do is to create a new entry in the all me array where the key is going to be that and the value is going to be this object. I guess if I show you the console.log, hopefully it'll make it a little bit clearer. So if I scroll down, you can see here, okay. So it's actually created an entry, just as I said there, where the key is the name of the variable and the value is the actual object. But really what I want is I want to spread the individual key value pairs in the part of me object. I want to spread them inside this containing object here. In other words, I want to get this effect here. And so the way I do that is I simply stick the spread operator in front of the kind of inner object, and it'll have the effect that I desire. You can revisit these little examples yourself if you're a little bit woolly on what I'm trying to get across here, or else ask questions. What am I doing? Yeah, another useful use case of the spread operator in relation to objects is if you've got an object, for example, is here, and I want to update one of the properties in that object. So I think in the example, what I want to do is I want to update the address. And here's the way I've done it. I've essentially what's going to happen here is this statement here is going to create a completely new object. That's okay. We're not overwriting the existing one. We're creating a new object. First part of the object is going to take all the key value pairs in the me object and spread them out. And of course, that now means that one of the properties in this new object is going to have the key address, and it's going to have the value 1 Main Street. But then straight after it, I have another entry which has the same key as one of the keys in me, but a different value. And effectively, the effect of the piece of code that I've highlighted here, the effect is to overwrite that key value pair in this new object. Because you can't have two keys with the same name in an object, obviously. So if me already has a key called address, and it's going to be part of this new bigger object, then what's going to happen to this one? Well, what's going to happen is what I've just said. It's effectively going to overwrite the address key value pair inside here with this new value. So when I do a console.log of updated me, which we see here, you can see the address is 2 High Street. So that's a nice kind of declarative way of updating an object. Admittedly, it's not strictly speaking updating this object. It's actually creating a completely new object. But that's okay. So it's not an override, it's a create new instance, I guess. And what's going on here? Oh yeah, that's the spread operator. Before I move off it, the last illustration here is using are we using the spread operator there? Oh yeah. It's not a case that you see very little, but you can see what's happening here. I've got a function that expects 3 arguments, and here I've got an array with 3 entries in it, and I call my function and I pass it the array. But because I've prefixed the array with my spread operator, effectively what is going to happen is the x, y, z parameters of my function are going to get the values 9, 10, 11. Yeah, you'd see that used in some places, but I don't use that particular technique, but there it is anyway. And okay, all that's happening here is 4 is going to be assigned to x, 9 and 10 are going to be assigned to y and z, and the 11 is going to be sorry, I said 0. I said 8, 9, 10, 11, 0, 1, 2. Sorry, I should have been saying there. 0, 1, 2 are assigned to x, y, z in this case, whereas in this case, 4 is going to be assigned to X, 0 is going to be assigned to Y, and 1 is going to be assigned to Z, and 2 isn't going to be assigned to anything. JavaScript is quite flexible in terms of function arguments. If you provide it with too many arguments for a function, it just ignores the redundant ones. And that's just it. It just allows you to do that. Wouldn't be a clever thing to do, but it allows it anyway. That's the spread operator. Default arguments, you can give default values for arguments. So this is kind of tries to illustrate every possible scenario for this particular function. Okay, it expects two parameters, X and Y, but I can give you a default value of 1 to X and 2 to Y. Does whatever it does with them. So when I call the add function with just 5 is going to be assigned to X, but Y is going to take the default value of 2. So that console.log should return 7 because it's just doing an addition of them. This one here, undefined 1, means that X is going to take its default value because we're trying to pass undefined and assign it to X. It's going to take its default value of 1, whereas Y is going to be assigned the value 1. And so it'll return 1 plus 1. And this one here, I'm not giving it any arguments. So X is going to get its default value and Y will get its default value. So it should return, console.log should output 3. Okay, that's default arguments. I don't use them as but I certainly use the spread operator and destructuring in the code, in our React code a lot. That's that. Back to React, I hear you say. So let's move on to adding navigation to a React app. Now I'm just going to exit out of this, which always calls, if I hit the escape key, kind of zoom, doesn't like it, but let's see. That's all. Bear with me now for a minute if you don't mind. What's the idea here? The idea is we want to give the impression that a React app has multiple pages or views in it. Just like in a traditional kind of web experience, we navigate, click on a hyperlink that brings us to a new page. And every time we click on a hyperlink, the browser's URL address will change and what we see on the screen will change. That's the classic web experience, as I said. We'd like that in a React context, but really all that's happening is when you click on a hyperlink, really all that happens is a whole bunch of React components are unmounted from the DOM and a new set are mounted onto the DOM. So we get a new view appearing on the screen, but in addition, the URL address in the browser is going to change as well. And so we like this idea of the URL address staying in sync with what's being displayed on the screen. If I can illustrate with the Movies app. So I'm just actually going to load the app as it will appear when you finish all the labs. It's a bit down the line, but and I'll do my npm start. Now, if you watch the URL address in the browser, so it's currently at localhost 3000 / essentially. But when I click on the more info button for a movie, I get a new page, and also the browser's URL address has changed as well. So it's staying in sync with what's being displayed. If I go to my favorites page, yeah, different URL address, different view. So that's, like I said, it's classic web experience. The thing though is, if I look at the actual source code, there aren't multiple HTML files in my project. In fact, there's only one physical HTML file, which is inside here. There it is. Where is it? Yeah, there it is there. And try though you might, you won't find another HTML file. Yet, as I showed you there a minute ago, it looks like I've got different pages, and that would kind of suggest I've got different HTML files. But we now know that really all that's happening is components are being mounted and unmounted. We've only got one single web page, this one here that I'm showing you. And that is where the term single page app comes from. Remember, we classified React as a single page app technology or single page app framework. Well, the single page refers to the fact that there is only one HTML file in your entire React app, yet you get the sense that there are multiple pages because the views are changing and the browser's URL address is changing. So that it's a single page application. It's an app because it has multiple views, but it's only single page. That's where the term comes from. Anyway, how do we actually achieve this? So that's kind of the objective. And it turns out that the React framework doesn't support it at all. We need to use a third-party library to do that. And that was a conscious decision made by the React team. By far and away, the dominant third-party library that takes care of navigation or routing is a library called React Router. And to illustrate how we use this third-party library, I provide you with some samples. You get the samples from the archive, and when you download it and unzip it and import it into VS Code, you'll get the following. So this is the archive that you've downloaded, and if I go into it, this is the folder that I want to look at now. So the way I approach this is I'm creating one React app using the Create React App tool, but if you open up the source folder, there are various samples. And so depending on what sample you want to examine, what you need to do is you need to go to the root index.js and just change the reference to the relevant sample in the import statement. Now again, there are some Zoom things popping up in front of me, so I just want to turn them off. Yeah, so just change this import statement to refer to the particular sample. And of course, you know, the Create React App server, once it detects a change to a file, it will go through its recompilation and all the rest. So start up your server as before, npm start. And I'll start by pointing it at sample 1. So it is pointing at sample 1, and sample 1 doesn't do a whole lot, but it's okay. If I change it to sample see, sample 4, let's say. Save it. And that's demonstrating something else. So let's step through the samples. I won't get through all of them today. That's not my intention. I just want to cover the samples that are relevant to this week's lab. So the kind of 101 case might be this, right? This is my objective. I want to have 3 pages, and these are the URLs that I want to associate with the pages. And this is the component that I want to have mounted onto the DOM for the corresponding URL. Now, in my case, I'm just mounting one component, but these components in real life would probably have child components and grandchildren components. There'd be each one of these would have a mini hierarchy of components linked to them. Okay, so but we'll keep it simple. We'll just have single components on their own. And so how do I express this objective? Well, we can do it in classic React code, really. But that's what's nice about the React Router library. Even though it's maintained by a completely separate team, they are keeping the syntax and semantics of it completely consistent with the way React works. And really, this is the first time that you've seen this code, but you could nearly work out what it's trying to express. It is very declarative in its nature. So there are some components that we are using that come with the library. So there's this browser router component. You've got to nest inside that, a routes component. And essentially these root component entries, we have one for each of the rows in my table on the left. And like I said, you could almost work out what it's trying to say. As in, this one here is saying, if the URL in the browser is this, then mount this component onto the DOM and replace what's currently attached to the DOM. If the URL in the browser changes to this, then unmount what's currently attached to the DOM and mount this component. This is kind of the default case, which is corresponding to this one here, the index case. And then this is catching the 404. So this is essentially saying if the URL is none of the above, then execute this. Now, navigate is a component. Navigate is a component that comes with the React router. And what that component does is it changes the URL in the browser to this value here. Now, whenever the browser's URL address changes, this component actually, that's essentially an event. This component reacts to that event, or it handles that event. And what it does is it essentially goes down through these entries here, looking to see which component should I mount onto the DOM as a result of the URL in the browser changing. So I'm going to just repeat that again. Every time the browser's URL address changes, and we'll see how we can change it in a minute, but every time it changes, this component, the browser router component, handles that event. And what it does is it looks at the URL in the browser address bar, and it looks for the best match. That's kind of important, actually. It looks for the best match. It won't necessarily take the first one. It'll find the best one. If it can't find any one of them, then that's where this entry kicks in. And this entry causes the browser's URL address to change again. In this case, we're getting it to change to this value here. Browser router handles that, and on this time, it's going to match up with this entry here, and it'll mount the home component onto the DOM. And that's really what I'm saying in all of that text there. And so sample 1 essentially is demonstrating that. So if we look inside sample 1 first, now just for convenience, I've packed all of my components into one file just for convenience. Okay, so here's my about component, my inbox component. As we get through these samples now, the notion is that we're developing a email client. Now that it's pretty glorified now to call it that. So that's where inbox comes from. My home component, and here's my routing configuration. And notice, oops, that's actually React 7 now. Sorry, I should have changed that, but it's this component. That's the one that you attach to the DOM initially. Thought I had that code now changed, sorry. That statement there, seeing as it's there now, I may as well explain it. That's the way, the pre-React 18 way of attaching a component directly onto the DOM. We do it slightly differently now in React 18. But just for now anyway, just try and bear with me. The component that you now physically attach to the DOM at the beginning of an app's kind of startup is the component that contains the routing configuration. So, so to run sample one, then, as I said before, you go into here and change it back to sample one. And so if I change the URL to /about, then the about page loads. If I change it to something that is neither about nor inbox, but something random, then the last entry in my routing configuration is going to kick in, which tells it to go back to the home page. And it goes back to the home page. That's the 101. That's how you express your routing requirements or your navigation requirements in a React app. And in the component that you put that routing configuration, that's the component that you manually, if you like, attach to the DOM. Hyperlinks, we don't use the HTML anchor tag. Instead, there's a special component that comes with the router library called the link component, which we should use all the time. What I'm saying here is that you should use the link component if you've got a hyperlink to some internal page within your app. Whereas if you want to have a hyperlink to some external page, then you could use the anchor tag, the standard HTML anchor tag for that. So here's our objective here on the left. We want to have 2 hyperlinks, and it's obvious what those hyperlinks should do. They should take us to the relevant page, although we now know that all that means is it should mount some components and unmount other components. This is how we use the link tag. So it's fairly straightforward, really. It has one property called the top property, and you set that to the URL address that you want to change the browser to. So the effect of the link tag, to explain it in kind of React terminology, the effect of the link tag is when the user clicks on the hyperlink, the browser's URL address changes to that. And once the browser's URL address changes, then the browser router makes a decision as to what it should do based on this routing configuration. Sample 2. Again, let's just glance at the code. And I've taken the lazy approach. I've packed everything into one file. So that's my home component, and it's the home component that has the hyperlinks in it. The other components are, I'm importing the about and the inbox component from sample 1 just for convenience. By the way, actually, that's actually destructuring going on there now. We use destructuring in our import statements as well. That's just by the way. And here's my routing configuration, which hasn't changed. And here's me using the old way of connecting a component to the DOM. Again, apologies about that. I should have changed that to React 18. But if I want to see sample 2 working, go back to my root index.js, change it to sample 2. Save, and there we go. Now, obviously, we would prefer to have these navigation links accessible from all of the pages, and I'll show you how to do that in a later sample. But that's the 101 illustration of hyperlinks using the link component. I'm just checking my watch, sorry. Next is something that React Router calls dynamic segments, but a better name, or a more meaningful name, hopefully anyway, is parameterized URLs. Let's suppose you want to have parameterized URLs as part of the set of URLs that your app supports. Here's an example of a parameterized URL where the 22 here is probably representing, more than likely, maybe a user ID. So in this fictitious app, let's imagine that when the browser's URL changes to that, then we display a profile page for user 22. If it's /user/23, then okay, it's the same page, but it's now going to display information about the user whose ID is 23. And we get that information from some web API or database or whatever. Similarly, this might be another example. This looks like this would display all the purchases made by this particular user. So the 12 and the 22 there are what we would call parameters within the URL string itself. And clearly it can be any value. So the questions arise are, number one, how do you tell the React Router library that this part of the URL is not a static part, it's actually a variable part? And secondly, then, the component that's mounted as a result of the URL in the browser changing to this, presumably that component would like to be able to access that particular value, as I said, possibly to make a web API call to the API that would grab the information associated with that user and return it back as a JSON object. So how does the component actually access that value? Well, the first question was, how do we tell the React Router that the particular part of the URL is a variable part? And if we bring it back to our inbox component, so now we'd like to be able to support URLs that are structured like this, where the 1, 2, 3 represents the user's ID. Well, in the route entry in the routing configuration, this is how you do it here. The colon here tells the React Router that this part here is a parameter or a variable. And I have arbitrarily decided to call the variable user ID, which is a meaningful enough name, I guess. So that tells the React Router that there can be any value here within this overall path. Secondly, then, and this is the component that I want to have mounted onto the DOM, but as I said a moment ago, presumably this component would like to get at the actual value that is on the browser's URL address. How does it do that? And do I have it here? No, we're told to look at it's on the next slide. Here's my inbox component. So there's a special hook provided by the React Router. As I said there at the outset, the React Router has stayed as close as possible to the programming model that the React framework follows. So the React framework introduced hooks in 2019. And similarly, the React Router library, it also provided hooks post that date. So this hook use params. It returns an object, and if you can destructure that object, and in this case, I'm looking for the key called user ID. And if it finds that key, which it should, because if I go back to the previous, because my route entry in the routing configuration, was expressed like this. So this expression here now is going to declare a new variable called user ID, and the value assigned to that variable will be whatever user ID is in the browser's URL address. And I'm just outputting it just to prove that it works for me. I'm not using it, but ordinarily, I guess I would have a use effect hook inside here, making an API call. And I think I've said all of that. So if we look at, there are other hooks as well, as we'll see, made available by the React Router library, which we look at the next day, I guess. But if we just quickly look at sample 3, I think we're on to. The inbox component I've just shown you, okay, we've seen that. And if we look at the index.js and in the routing configuration, you can see here we have our parameter part in the URL, or in the path part, if you like. And the way I try to prove it, that it works, is I have 2 hyperlinks. And if I click on this hyperlink, and again, watch what happens in the browser's URL address bar. Okay, so 1, 2, 3, 4 is the user ID. This output here is generated by the inbox component, and you saw in the slides that the inbox component just echoes the user ID, and so it seems that it was able to pick up the value correctly. And the second hyperlink changes it to 5, 6, 7, 8, and again it picked up the value. So that use params hook was able to give me access to the parameter part of the current URL address in the browser. Right. Guess we'll park it there for today, and I'll pick up the story the next day with you. Again, if there are any questions, either on what I've just done or on the labs, feel free to shout now if you have any.